Unit 4. Today we're going to be talking about the constant rate of change and direct variation. So basically last lesson we were talking about slope and rate of change of a function of a line. And basically this time we're going to be focusing on what that change means to the x and the y values. So basically the x and y values aren't just x and y, they're talking about time and distance and things like that. So basically we're going to be talking about how that rate of change affects those two items. Okay? So first of all, a linear relation is basically any type of relationship with a straight line graph. So if you're saying how many miles per minute, so obviously that's going to make a line because each time the distance gets further, the time is going to get longer. So that's why those two items together, when they're related, they make a line because as one goes up, the other one goes up. And so they kind of meet together to make this line. Now the constant rate of change. So basically this is just the fact that it's not just the rate of change between 2 points. It's that rate of change is going to be from those 2 points and the next 2 points and the next 2 points. So the relationship is going to be the same. So it's not going to be any graphs where it like goes up for a little bit, goes down for a little bit, and then goes up for a little bit. That's not a constant rate of change. Those we would have like 3 different rate of changes there. But we're talking about one straight line. So just going straight up like this, straight down like that, and it will not go anything like this or go up and down or anything like that. So it's going to go in a straight line because as one increases, the other one increases, or as one decreases, the other decreases. Alright, so let's go ahead and look at the direct variation and constant variation. So basically what does that mean? In order to find these two things, we're going to be talking about certain equations. So we have y equals k times x, or k equals y divided by x. So what does that mean? Basically, anytime you're given a formula, you're going to take those, the formula is all of variables and things like that, and you're supposed to use this to plug in things to solve for things. So every once in a while, they'll give you an x and a y coordinate, and you have to plug in the x and y and solve for the constant, or the constant of variation. Or they will give you like 2 parts, and you're going to have to solve for another one. Or they can take the constant and tell you to predict how much of something else, and you'll solve for either the x or y value. So basically we're going to use these equations to go off from. Okay, so the x in the equation stands for the x coordinate, the y stands for the y coordinate, and the k stands for the constant of variation. So an example of this would look like you start off with a chart. Okay, you have 2 x values and 2 y values. So we have 2 points on this line. And the x values are representing the amount of information that is stored on the CD, and the y stands for the time. So how long is it going to take? So basically you can write an equation. So you're going to be asked, okay, here's your information, now write an equation to show the constant of variation or something like that. So basically what I would do, I picked out 1 point. I have an x value, I have a y value, and then I do not know my k yet. So I have 10 equals, because 10 is my y value, so 10 equals k times 2.5. That would be an example of setting up an equation. So all you're really doing is putting in an x value and a y value from the chart, or from the graph, or from a list of ordered pairs. Okay, so then you can go ahead and actually use this equation to solve for the constant of variation. In order to do that, you just solve for your variable. So we're doing a one-step equation. In this specific case, we're doing k times 2.5. So we're going to go ahead and divide by 2.5 to figure out what k is. So we'll do divide it on both sides, and then we're going to get k is equal to 4. So basically our constant of variation is equal to 4. Now we can use that information, that our constant is 4, to predict. So for example, we have how long will it take to fill a 700 millibyte or megabyte CD. So how long is it going to take? So if you look back at our chart, we have the x value stands for the amount of information, or the megabytes, and the y stands for the time. Okay? So what I would do is I have my constant, right? So I'm going to take my constant, and I'm going to plug it in for k. And then I'm going to plug in 700 for x, because x values represent the amount of information, and if it's giving you the how many megabytes it is, it's giving you the x value. So then we're going to plug in 700 for x and do 4 times 700, and you're going to get 2,800. But 2,800 what? And we have to remember what the Y stands for. The Y stands for time, and in this specific case, it's talking about seconds. So it's going to take 2,800 seconds to burn that type of CD. Okay? So now let's go ahead and use this information to do some examples of our own. All right. Number one, example one. The first thing you want to do when you get a question like this is really look at your chart, because once you start reading this, it's not going to make much sense unless you know what information is presented to me and what does it even mean. So first of all, we're talking about a square that's growing. So a square that's getting bigger. So obviously if a square is getting bigger, the perimeter is going to grow. So we have our perimeter increasing, and our perimeter is represented with the units centimeters. So we're moving in centimeters. Also, we have number of seconds. So obviously, we're having some sort of relationship where the time is increasing and then the square is getting bigger at the same time. So how long is it going to take for the square to get so big? So that's what we're looking for here. So it's kind of a strange example, but let's go ahead and try to work with it. So it says, on an advertisement, there is a square icon that increases in size. Find the constant rate of change. Describe what the rate means. So good thing is, constant rate of change, we're basically going to do the same thing like we did to find the rate of change or to find the slope. So first thing, we need to find 2 points that lie on the line. So I'm going to look at my graph, and I'm going to follow my line until I see 2 places where the line crosses an intersection between these like lines in my graph paper. So first of all, I'm going to keep going, and I run into this point right here. This point, I had to go over 2 and up 3, so that point is 2, 3. Now I'm going to keep following on until I get another point. And here's one where we had to go over 4 and up 6. So our point is 4, 6. So now we have our 2 points, and we're going to find the change in y over change in x. So first of all, let's look at our y values, because we always look at our y values first. So to go from 6 to 3, do we go up or down 3? So basically, we're going up 3 to go from 3 to 6. So we're going to have 3 over. Now let's look at our y values. How much do we have to go up to go from 2 to 4? We have to go up 2, right? So we have 3 halves, or 1.5. So now, what does this mean? It says describe what this means. So basically, in the numerator, we have our y values, and the denominator, we have our x values. So let's go ahead and look up here. It says that the y values over here is standing for the square. So basically, our square is increasing what? 3 centimeters per. Now, anytime we say per, we're talking about dividing. So per 2 what? 2 seconds. Because we know that this is our x value and the x values are representing with seconds. So per 2 seconds. Or you can write it as increasing 1.5 centimeters or 1.5 centimeters per second. So all I did to change it from 3 centimeters to per 2 seconds to 1.5 centimeters per second, I just divided by 2 to figure out how much per second instead of per 2 seconds. So this would be kind of an example of what I'm talking about when it says describe what this means, okay? Let's go ahead and look at another example.